of rational functions by where Qx is not equal to 0. Let us take this case 1. If Qx contains non-repeated real linear factors. Here, thank you. X dx x plus 1 into 2x plus 1, x plus 1 into 2x plus 1. You see this denominator Qx contains two factors. They are non-repeated because there is no square term or cube term, and the powers of this unknown variable x is 1. So these are non-repeated real linear factors. Now for solving, we take this, let excluding dx and integration sign whatever is there, like this, ay first factor is b by second factor a by x plus 1 b by 2x plus 1 a b are constants. So this implies x by x plus 1 into 2x plus 1 is equal to x plus 1 into 2x plus 1 a into 2x plus 1 plus b into x plus 1. We cancel this. That implies x is equal to a into 2x plus 1 plus b into x plus 1. Now our intention to find the values of a and b. So we put this, if x is equal to minus 1, then we will get minus 1 is equal to a into minus 2 plus 1 plus b into, this becomes 0. So that is minus a plus 0, which implies a is equal to 1. If we put x is equal to minus half, we get minus half is equal to a into 2 into minus half plus 1 plus b into half plus minus half plus 1. So this becomes a 0 plus half b, that implies b is equal to minus 1. So we have found out the values of a and b. Now we can put here to integrate. So integration x dx by x plus 1 2x plus 1 is equal to integral dx by x plus 1, because value of a is 1 here, so it doesn't have no contribution, and b is minus 1. So this becomes dx by 2x plus 1. So this becomes ln x plus 1, and here we can adjust here by multiplying 2 and dividing this. So this will be minus half ln 2x plus 1 plus c. Now this is the case 1. Now let us discuss the case 2. Case 2, if qx contains repeated real linear factors like this, suppose this x plus 1 square is there. So I will choose this a, here we have to change this here, that is some little change here, that is a by the repeated factor plus its power is to reduced by 1, then plus c by 2x plus 1. That means, and following the same procedure, you can solve this for ABC and you can get the integration. Suppose this is 3 here, suppose 3, 2, 1 like this. Now let us case 3, let us take the case 3. If qx contains non-repeated quadratic and real linear factors. We have to take an example. Let us take the example so that our doubt will be clear. Yes, 4x square minus x plus 3 by x square plus 1 into x minus 3. This is a CTC question. Yes, this is a CTC question. It has come in the exam 2005. You see here this problem comes under case 3. Why? Because you see this is non-repeated, this is a quadratic factor, because the power of the unknown x is 2 here. This is quadratic factor and this is linear, right? So how we will proceed? Excluding dx and integration sign, let 4x square minus x plus 3 by x square plus 1 into x minus 3 is equal to, you see, you have to write like this: ax plus b by quadratic factor plus c by real factor. This is real factor, this one is quadratic factor. Now we have to solve to find out the values of a, b, c. Let us see how we can solve in the easier method. You see, 4x square minus x plus 3 divided by x square plus 1 into x minus 3 is equal to ax plus b whole into x minus 3 or c into x square plus 1 divided by x square plus 1 into x minus 3. We cancel this, so we get 4x square minus x plus 3 is equal to, that means there are very easier method I am telling one, that is ax square. Let us multiply this, minus 3ax plus bx minus 3b plus cx square plus c, right. So that becomes 4x square minus x plus 3 is, let us this taken x square common, so we can write this a plus c into x square, right. Now you can do this, this is plus minus 3a plus b into x, right. Then what remains is c minus 3b. Now you can write equating coefficients of x square, x and constant terms on both sides, constant terms on both sides. What you get? You see, here in the left hand side x coefficient of x square is 4, while in the right hand side coefficient of x square is a plus c. So what we get? That implies a plus c is 4. Achha, come here like this, minus 3a plus b is minus 1, minus 3a plus b is minus 1, and what is our constant? That is c minus 3b is equal to 3. So after solving these three equations, we can get the values of a, b and c, and you can put in here, you can get the answer. Let us solve this, find out the values of a, b, c, right. Now the case 4, let us take case 4. Equation contains repeated quadratic and real linear factors. That means this case, this is repeated and this is repeated. Then how you will proceed? This question is never asked in the examination because of more number of constants, but only we have to know the process, because this question is never asked in council examinations. Let 4x square minus x plus 3 by x square plus 1 2x square into x minus 3 square. That is, you see, I have told you about this, that is x square plus 1 square plus cx plus d by x square plus 1. You see, this is repeated case, so we have to reduce the powers one by one, then we come to this linear repetition. Now 4 constants are there, then e by x minus 3 square plus f by x minus 3, where a, b, c, d, e, f are constants. By solving we get values of a, b, c, d and integrate. Thank you. Now let us go to fundamentals theorem of integral calculus, that is most important one. First fundamental theorem. Yes. Let f is equal to 1. Let f is a function from a to b2, set of real numbers, b a continuous function let the function g be defined by gx is equal to a to x ft dt then g dash x is equal to fx for all x belongs to ab. Right. Now second fundamental theorem of that is concerned, that is definite integral, right. Let it be the right if be the antiderivative of f in ab, where f is continuous in where f is continuous in ab, that is dash x is equal to fx, yes, then a to b, I mean fx dx, yes, dx is equal to fb minus fa. Okay, and this where a is called lower limit, b is called upper limit, and obviously a is less than b. Then we will go to this definite integral and we will solve the problems on the definite integrals. Let us take some problems here. Right, let us evaluate. Integration 1 to 4 x plus 5 dx is a very simple question which comes under definite integral. You see, you have to follow the same rules of integration. We have to integrate term by term. As you know, the constant will go outside the integration sign. You see, here lower limit is 1, upper limit is 4, and you know this formula. I have told you this formula. This is the most important one that we will have to apply here. In case of indefinite integral, we are the constant of integration, but here in definite integral, no need of adding this constant of integration. You see, this becomes x square by 2 is 4 1, and this is simply x 4 1. So, this is yes, this is 2 times this is 4 square by 2 minus 1 square by 2 plus 5 is 4 minus 1. This is 2 whole into, you see, 16 by 2 minus half plus 3 is 2 8 minus half plus 15. This is 2 whole into by that is the answer, right? Yes. Achha, let us take another one trigonometric one. Let us take second question. Is this 0 to pi by 4, 0 to pi by 4 tan square x dx, right? We know this because tan square x, you have to split this. We know sec square x minus 1, right? Now applying the addition rule of integration, this becomes x square x dx minus 1 dx 0 to pi by 4, and you know this. Which derivative is this? Is tan x derivative is x square, so its answer is tan x, and this is upper limit is pi by 4, lower limit is 0, here is x, here is upper limit is pi by 4, 0. So this becomes tan pi by 4 minus tan 0 minus pi by 4 minus 0. So tan pi by 4 you know was 1, this is 0, and this is 0. So you get 1 minus pi by 4 is the answer. Now let us read some properties of definite integrals. I will write this from properties. The most important properties I will write here. Yes. Yes, 1 a to b f x dx is equal to a to b f t dt. Yes. What happens here? By changing the variable the value of integration remains same, the value of integration remains same. These are most important for examination point of view. Please record those things and also see if I change these variables lower limit to upper limit, you see what happens here. This first formula implies also that here is variable is x, here is variable t. You may take some other variables as you like, but the value of the integral will remain same if you change the variables. Here you see this is a lower limit, this is upper limit. If you change this, because a is less than b, if you change this, you will get a minus sign here, right? As a to a f x dx is 0. Third one. Yes. A to b f x dx is equal to a to c f x dx plus c to b f x dx, where c is an intermediate point between a and b. As c is a point in between a and b, so you can split the interval of the integration like this. Okay. Yes, this fourth one is most important one. A to b f x dx, this one important one, is equal to a to b f a plus b minus x dx. Yes. And fifth one, 0 to a f x dx is 0 to a f a minus x. This is also one important formula. Right. And sixth one is 0 to 2a fx dx is 0 to a fx dx, 0 to a dx plus 0 to a dx. And seventh one is yes, 2 times 0 to a fx dx if is even function, right? If f is an even function, then you can split this formula to this and is equal to 0 if f is an odd function. You know this odd function and even function in the first year, I hope, because if f minus x is equal to minus of x, then it is an odd function, and if f minus x is equal to plus of x, then you can get even function. The example here is cos x is an even function, and here example is sin x. This is an odd function, right? Now let us take some Wallis formula is there, the most important one. Let us write these things for evaluation of definite integrals. To find the so this is most important Wallis formula. Now let us go to the application of integration. by applying integral calculus, we can find area, length of a curve, area under a curve, length of a curve, volume, and so on. But we are interested to find the area under a curve. Area under a curve in a plane region. If the equation of curve is given as y is equal to fx two ordinates, two lines, that is you can say ordinates x is equal to a and x is equal to b given area is equal to y dx, x is equal to a to b. Here a is the area bounded by x-axis curve y is equal to fx, curve y is equal to fx, and two lines, ordinates x is equal to a, x is equal to phi. You see the figure how it comes. This is the curve y is equal to fx. Now take this line. This is x-axis. This line is x is equal to a. This line is x is equal to b. So this area is equal to a, which we represent by this integral. Now let us come to another side. If the equation of curve is given as x is equal to fy, two lines, that is FC stars, are y is equal to c, y is equal to d given, then area is c to d x dy, where here a dash, let us take, it will not be confused, where a dash is the area enclosed by or bounded by, enclosed by, here it was x-axis, here it is y-axis. Y-axis curve x is equal to fy and two lines that is axis, as we have told, y is equal to c, y is equal to d, and the figure will be like this. This is y-axis, and you can see this y is equal to c, y is equal to d. So this portion is the area A dash. Now let us do some problems. Another thing, area enclosed between two curves. Let us take another formula, right? Area enclosed between two curves, y is equal to fx and y is equal to gx. And the lines is equal to b. A is equal to a to b fx minus gx dx. Yes, where fx is greater than equal to gx in a. Now let us do some problems there. Question: find the area. Find the area bounded by y is equal to x square, y is equal to 0, x is equal to 1. right? You see here area is, because x varies from 0 to 1 and we know y dx, value of y is x square and this is x cube by 3. So this area is 1 by 3. Let us take another question. Find the area this is y dx form. Now let us take x dy form. Find the area bounded by the curve x is equal to y square and the straight lines x equal 0, y is equal 1 and the straight lines x is equal to 0, y is equal to 1. Here you see in this previous question y0 is, this is x axis, nothing. Simply here is, this is y axis. So you see how we will find the answer. Area is here. You see this curve is, here it was y in terms of y, here in terms of x. So this will x dy, right? And here x varies from 0 to 1. So this will be y square dy 0 to 1. This will be y cube by 3 obviously, and the answer is same, square units.